we have to do this experiment now, and because of that, well, it doesn't matter how I hold it here. On Earth it's important to keep it in a certain way, but here I can hold it in any way. There's no up and down. So I'll demonstrate to you this experiment now in weightless conditions. And we need a good background, and I come a bit closer to you. My hand is just as warm as it was on Earth, and I'm transferring the same amount of heat into the water. And the water in the convection loop is therefore becoming less dense. However, despite the fact that heated water on Earth and in space both become less dense, the outcome is definitely not the same. It seems from this experiment that gravity is necessary to observe the flow of convection, because gravity, or weight, is the only difference between the experiment here on the ISS and yours on Earth. As you could see, no real effect, nothing moved. So, this is the result of our experiment here in space. And I would like to know if your hypothesis was correct. Did you have the right idea? So what is happening? Well, if you heat something up, a fluid, then under my hand the molecules get more energy. They start to move more, they vibrate more, they need more space, they push each other off. That means that they get less dense. Less dense means less mass. Means if the gravity is there, if it pulls on it, there is a difference between the warm liquid and cold liquid. So warm liquid goes up. You can feel it if you swim, for example. If you go deeper in the water, it becomes colder, and higher on the surface it's warmer. And in space that doesn't happen. So warm fluids do not go up because there is no up, there is no down. So that's the big difference. As part of the ESA mission, the PROMISE mission, we have an educational program called Spaceship Earth. And with Spaceship Earth we're going to demonstrate several things, and one of them is, for example, convection on Earth. And I'm here now in the cupola, and the cupola is a fantastic place where we can see the Earth 360 degrees around. So I'm going to show you some interesting views of our planet, and also some aspects of convection. It's very clear that convection is happening all over Earth, in the atmosphere, the water, and even inside the Earth. Gravity, that's the force that affects the direction of the flow, is one thing that allows this convection to take place. All these convection processes that I can see here from space are similar to the small experiment that you can carry out yourself. From space you see a lot of different cloud patterns. And clouds are a nice example of convection. So it's the warmer air that goes up, and then it comes to the cold layers, and the water condensates and forms the clouds. So without convection we wouldn't see all this. And there's a lot of different shapes here in the clouds, and it's very beautiful to see. And here we fly over the Alps, and you see a lot of snow. And the convection also means different kinds of temperatures on different kinds of altitudes, and it creates a big difference in plant life and wildlife. The Alps are beautiful, lots of snow. Now here we can see the island of Sicily under the clouds, and on there we have the volcano Etna, which is actually active at the moment. And volcanism is also one of the demonstrations that we have of convection on Earth. Because of the liquid mantle of the Earth, there's also convection going on deep below us on the planet, where the magma is moving through convection, and at points of volcanoes comes out of the Earth's crust. Now here we're flying over an ocean, and hypoconvection is actually a small-scale version of the water that is flowing in the world's oceans. And near the poles of the Earth the water cools down, and the remaining colder and heavier water then sinks and flows across the bottom of the oceans all the way to the Pacific on the other side of the world. So salinity also affects convection. Salty water is denser than fresh water, and therefore the salinity is also affected by gravity. So here we're going over East Africa, and here is an interesting phenomenon as well, because here you have a lot of volcanoes. For example, the Ngorongoro crater and Mount Kilimanjaro, which is visible over there behind the Soyuz. And volcanoes are also in the something that has to do with convection, even of the liquid mantle of the Earth. Also there convection takes place, and the fluid magma comes up. So I hope you like this lesson. It's very interesting to be here. It's fun. Weight is important for a lot of processes, and if you don't have it, things are very different, as you could see here. Okay, I hope you liked your experiment on ground, and you liked how we did it in space. I would say, auf Wiedersehen, au revoir, tot ziens, adios.